All right, welcome to Cruz Learning, where it's just that easy, with your favorite host, Professor Cruz. And today we're going to talk about solve systems of linear equations by graphing. All right, so the first problem says in solving a system of equation by graphing, which of the points labeled shows the solution to the system of equations? So from the previous 2.1 lesson, hopefully you remember that if I give you a system of equations in a graph, the solution to the system is wherever they cross, wherever they intersect. So that's it. That's the point. Then, therefore, the answer is E. That is the labeled point over here. That's an answer. Now, sometimes I will ask you a little bit more specific questions. Like, for example, what is the value of the point? What is the point? And they'll give you A, B, C, D, E. So if I ask you for that, you actually have to find the value. So the X value of that point looks like it's right exactly between -1 and -2. So that'll be -1.5 for X. And for the Y value, that looks like that will be right between 3 and 4. So that is 3.5. That's how you will find the value of the solution of these systems of equations. So remember, the systems of equation, the solution is a point, is always a point, not just a number. And it's always X, comma, Y, X, comma, Y. I hope that that makes sense. If you forget your axes, then make sure that you label them X, comma, Y. Now, there's other things, interesting things that I can see over here. I'm going to label this in green real quick. If I ask you from the equations that you have in the graph, where these lines have a y-intercept. Well, it looks like the y-intercept for these graphs, if I go to the top, from top to bottom, A will be the point of one of the lines of the y-intercept, and D will be the other y-intercept. Remember, the intercept is wherever the line crosses the y-axis. That's why it's called the y-intercept. How about the x-intercept? Where are the x-intercepts for these? Well, I'm going to draw this in red. And the x-intercept is wherever these lines cross the x-axis. So from left to right, that will be a -5, so C, and a +2, B. Okay, so those are the points that they label. Just make sure that you know the solution to this answer, to the system of equation, is that point. All right, perfect. Let's do number 2. Solve the systems of equation by graphing. So now we're going to graph. Well, do you really have to graph? Here's a trick. You don't have to graph every single time. You have to graph when there's actually one solution. Every time there's a one solution, we need to graph it just like the previous problem to find out where that point is. But before I graph this problem, let me check one thing. Do they have the same slopes? Well, the first step, always, to solve any of these problems is to write your slope-intercept form. Your answer needs to be in slope-intercept form so that you can clearly see the slope, right? If I write it like that, then I can clearly see M right here, M, which is my slope. And by looking at the slope, I will be able to tell. Well, if we look at the slope of the first equation, it looks like it's +1, right? The coefficient of x, when you have a variable and there's no number, is 1. And the coefficient of the second equation is -1, all right? So in this case, the equations do not have the same slope. But let me explain real quick what happens if they do have the same slope so you don't have to graph it. Let's assume for a minute that the first equation and the second equation, they both have +1 slopes. They're both positive. So they have the same slope. The last thing that I need to do is just look at the y-intercepts. Remember, B is your y-intercept. So because they're different, one is -3 and the other one is -1, if I try to draw these graphs right, so this is not accurate at all. I'm just graphing a line that goes to 3. I'm sorry, that's +3. Like I said, it's not accurate. A line that goes through -3 and a line that goes through -1. Okay, they are not intersecting. They're parallel lines. I know they're parallel for sure because the slopes are the same. We learned that last chapter. And because they're different y-intercepts, they're parallel lines and they never intersect. Therefore, there is no solution. So, if you have the same slope, right? Same slope. So let's write that down. Same slope, but different y-intercept. In your answer in Canvas, you're going to write down D and E, which means does not exist. there's no solution. They never intersect. Okay? Now, what happens if when you get the same slope, so again, we're assuming that both equations have positive ones, these numbers were the same. The first one is -3 and the second one is -3. Well, what happens here is that you get the same equation. It's the same line. They're identical equations. Therefore, that will be like me drawing a line -3 and then drawing the second line right on top of it. That means that every single answer, every single point is on the other line, making this infinitely many solutions. And when you go to Canvas, okay, what you're gonna write is double zeros, comma, double zeros, because those are like infinity signs type of thing. So this will be identity or infinitely many solutions. I'm gonna write identity because it's shorter. That will be the same slope. Ooh, let me fix this. Same slope, right? Same slope m. So make sure that you make this change because I made a mistake when I wrote it first. So same slope, different y-intercept for infinitely many solutions are both the same. The slope is the same and the y-intercept is the same. All right. So with that being said, any of those two cases, you don't need to graph. This one we need to graph because the slope is not the same. So slopes are different. One is +1, the other one is -1. So let's graph it. The first thing that I plot is the y-intercept. I'm gonna draw the first line in red. So I'm gonna go to -3 and I'm gonna place a point. And then my -3, my goodness, there we go. And then I use my slope, which is 1. So I write the slope of the first line as rise over run. So just remember that slope is rise over run. So by looking at the first equation, I will have to write 1 as a fraction. So that's 1 over 1, which means I'm going to go up 1 from my y-intercept and over 1. And that's my new point. And I'm going to continue to do the same thing over and over and over and over and over, right? Over and over and over and over. And that way, I'm going to have the slope. All right. For the next one, we are going to do the same thing. And we're going to do -1 and -1. So I'm going to go to -1. That's my y-intercept. Remember, it's always the number by itself. Okay, the number by itself. And then I look at the slope and it's -1. So the slope, which is -1, is rise over run. I'm going to write it as a fraction. So from that point that I just graphed, I'm going to go down 1 because it's negative and to the right 1. I always go to the right. Always move to the right. And then we have that point because down 1 over 1, down 1 over 1. If I go the other way, well, you get the point. Hopefully, get it? Get it? I hope you get the point. All right. And then you're going to find out whenever they intersect. Where do they intersect? Well, they intersect this right here. They have the common point, and you have the x value, and you have the y value. Okay? So if I were to answer this question, and they give me find the intercept, then the solution to this problem will be the point 1, comma, -2. Always x, comma, y first. X, comma, y. I hope that makes sense. I hope that makes sense. Now, they don't only ask for this in this problem. Let's see. Oh, no. Yeah, that's the only thing that they do. They ask you to graph it, so that's it. That's the answer. So the right point, right, the intersection is the black point that it's right there. Let's do the next problem. Let's do the next problem. Number 3. Consider the following systems of equations. And isn't it that nice? They graphed it for you. Perfect. Okay. They say, what is the solution of the system? So if you have a graph, you should be able to find a solution by looking at it. Okay, so it looks like my solution is right there, wherever they intersect. So what is the x value and the y value of that point? So label your axis if you're not sure. This is x and this is y. Always, always. Y is the longest one, it's going down. All right, so the x value looks like it's right in between -2 and 4. What is right in between -2 and 4? -3, right? So then that will be -3, comma, and the y value is right between +2 and 4. So that will be +3. And it's just that easy. Just by looking at it, we found a solution. Okay, now let's do the second part. In the boxes below, enter either the letter A or B to match the equation to the graph shown. Okay, so which equation is which? All right, so graph A, okay, well, let's do it. Negative 4x minus y equals 9. That's graph A. So how can I tell? I'll need to rewrite this, okay, as y equals mx plus b. So remember, every time that you get any equations in this scale, you will always change it to slope intercept form. So in order to change the slope intercept form, I'm going to have to move this negative x to the other side of the equal sign, and I could do that as long as I change the sign. So I'm going to have, for the first equation, I'm going to have negative y, because the negative stays there, equals, now I'm moving the negative 4x, that's the only one that I'm moving, so that one is changing signs, positive 4x, and the positive 9 stays there, plus 9, okay, plus 9. So when you have that, what is going to happen is that y is not by itself because it's being multiplied by negative 1. So I'm going to have to divide every single term by negative 1 so that I can solve for y. And when that happens, I get that y equals 4 divided by negative 1 is negative 1, 4. X, 9 divided by negative 1 is just negative 9. So right there, I can see the slope. The slope is negative, and the y-intercept is negative 9. So when I look at my equations, I'm back to my graph, and I look at my line, does any of these line has a y-intercept at negative 9? Yes. The red line crosses at negative 9. And then double check your intuition. Is it a negative slope? From left to right, is it going down? Is it going down? And the answer is yes, because if I try to draw this, notice how let me change the color. Notice how my stylus has to go down from left to right. Therefore, this is a negative slope. So the first, the red one is graph A indeed. So this will be the red one, graph A, which is labeled right here. Okay, hopefully you can see that, the A right there. So that's A, and the other one is B in this case by default. All right, so that's how you do it. Let's do number 4. Now, they want you to solve the system of equations by graphing. There's no graph here. So you have two options. The number one option, now hopefully you have the graphing calculator. All you have to do is go to your graphing calculator. You'll find a button that says y equals on the top, and you're gonna press that button. Then you're gonna enter both equations, and then you're gonna press the graph. And when you do that, it's gonna graph them for you, okay? Once you do that, then you could hit enter, you could hit second and 5 so that you could trace the point. You hit enter 3 times, and then you will be able to find a point. But what happens if you don't have it right away? Well, you could use Desmos, okay? And I've always used Desmos for the longest now. It's a graphing calculator, and it's great. So I have to go back, and I'll have to solve for y equals mx plus b, right? So let's go back to my equation. Oh, perfect. It's already solved. So all I have to do is write negative 5x minus 27. So I go to my Desmos and I write down that y equals, all right, negative 5x. So negative 5x minus 27. So there's my first graph. Okay, and then I go to the second graph and I go to y equals, remember, you got to solve for y equals mx plus b, negative x, okay, negative x minus 7. Now remember, you can do this in different places. Now, it doesn't matter which calculator you use. The idea is that you find the intersection. And it looks like we found the intersection right here, right? It looks like we found the intersection. That's where they cross. You could click on it, and hopefully it will show you a point, and it will tell you which point it is. The actual graphing calculator tells you the point at the bottom. And if you look, let's see what happened here. So if you look, it looks like the answer is negative 2, a -5. Oh, I'm sorry, -5, comma -2. Always look at your x value first and then your y. You see what I did there? Okay, so -5, comma -2. So I'm going to go back here, and the answer is -5, comma -2. You definitely want to use a graphing calculator for these type of problems until you learn how to do it algebraically, which we will in the next section. All right, the last problem. Are you ready for the last problem? I want to do this problem. Actually, I'm going to do 2 more. Number 5, solve the systems of equations by graphing because it looks weird. But you can do this. All you have to do is rewrite this equation in the y equals mx plus b form. So in the top, it looks like x is on the left and my constant is also on the left. All I have to do is move them to the right side of the equal sign, and that will change the sign, right? So I'm going to write down my equal sign, and I'm going to move. If I move -1x to the right side of the equal sign, that's going to turn into positive 1x, or just positive x. And if I move +3, it's going to turn into a -3. Y, it's on the left side, so it's going to stay there. And I already solved it. Okay, y equals mx plus b. I could do the same thing at the bottom. I'm going to have to move the -5x and the 27. So this is going to turn into -5x, right? -5x plus 27, because 27 is negative. Now it's going to turn to positive. Okay, I look at the slopes. The slopes are different. The slope for the first one is +1. The second one is -5. So I will have to graph this. Okay, so again, use your graphing calculator. Find a solution to this problem. If you would like to know, I could tell you the answer so you could check if you did it right or not. If you graph it, you should get 5, 2. 5, 2. All right, the last problem that I'm going to do is this one. This is a very interesting problem, so pay close attention. Solve the systems of equation by graphing. But do you really have to graph? We'll see. I could go to the first equation, and again, my first job is to change it to y equals mx plus b. So I'm going to have y equals 5 is going to turn into -5x plus 1 plus 21. So that's my first step. And my second step will be to rewrite the second one. Now, the second one, I will have to divide by -2 on both sides because that's the only thing that's missing. Y, the term of y is already on the left. It's just it's being multiplied by -2. So using inverse operation, I divide by -2. And I'm going to get that y equals 10 divided by -2 is -5x. And -42 divided by -2 is plus 21. Hey, look what happened. They're both exactly the same. So because they're the same, the question is there infinitely many solutions or is there no solution? The answer is not going to be a point. The answer is either infinitely many points or no point at all. So I have the same slope. Okay, so same slope. And when I look at the y-intercept, I have the same b, or the same y-intercept. B represents the y-intercept because they're both the same. That means it's exactly the same graph, the same line. So there's infinitely many solutions. So in Canvas, you enter 2 zeros representing the infinity signs. So I hope that this makes sense. This was Professor Cruz with eCruz Learning, where it's just that easy.